2, 3.
All right, now we're going to talk about two more types of chemical reactions. The first one is called single replacement. Okay, in a single replacement reaction, there's actually two types. And what you're going to see is that you're going to have an element plus a compound, and you're going to create a new compound plus an element. Now, the reason why there's two types is because that element that's by itself can either be a metal or a non-metal. In this case, it's called a single replacement anionic reaction. An anion, remember, was a non-metal earlier this year. A non-metal was an anion. So if I have an anion plus a compound, okay, then I'm going to have a new compound plus another non-metal. Okay, so here's an example. If I have chlorine, which is a non-metal, plus HBr, which is a compound. Remember, two or more things make up a compound. A metal and a non-metal make up a compound. It's going to produce, this chlorine is going to come in and kick out the Br and get with H, so it's HCl plus Br. Now remember, Br is diatomic, so it can't be by itself, so that's why there's two of them. And we'll get to balancing later and making sure that we have the right number of atoms of each element. But right now, I just want you to be able to recognize the types of reactions. So you have a non-metal plus a compound makes a new compound plus the non-metal that got kicked out. So the other type of single replacement reaction is called single replacement cationic. And remember, a cation is a metal ion. So in this case, I'm going to have a metal plus a compound, and it's going to produce a new compound plus a metal. So what happens in this is this metal ion comes in and kicks out the other metal ion. So lithium is going to come in and kick out Na. All right, and it's going to get with Br. So then the product's going to have LiBr plus Na. Now I use things that are really simple. They're all +1, -1 oxidation numbers. So they're all really clean. You're going to have to make sure that when a compound's being made, that those oxidation numbers cancel out when you write it. So that is a single replacement cationic reaction, where you have a metal plus a compound makes a new compound plus a metal. The last type of reaction for today is a double replacement reaction. And the way you recognize a double replacement reaction is you have a compound plus a compound. Now remember, a compound is a metal and a non-metal combined, plus another compound, and you're going to produce a new compound plus another new compound. So you're going to have a plus sign in the products and in the reactants, okay? And so it would be like AB plus DC. In this A, the cations are going to switch partners, okay? So that D is going to get with B, and that A is going to get with C and produce new compounds of AC plus DB. So if we want to look at this, we have NaCl, which is salt, plus HBr. The Na and the H are going to switch positions. They're going to swap partners. It's like if you're going to a dance, you're going to switch dates. So you have Na is going to go get with Br, so the product is going to have NaBr, and H is going to get with Cl. So H is with Cl over here. All right, and so you're making a new compound, but you still have to have metal with non-metal and metal with non-metal. You can't have Cl combined with Br. That doesn't work. You can't have two non-metals making a compound, and you can't have two metals. Like you can't have Na and H making a compound either, because that's two metals. So a double replacement reaction, the way you tell is a compound plus a compound. All right, so you're looking for a metal non-metal plus a metal non-metal, and those metal ions are going to switch partners and make new compounds. So that's double replacement and single replacement.